everyone, I am Suyat Pednekar. Welcome to Build Coders. Today we are going to discuss a very interesting 1200 rated problem which looks like a simple math puzzle, but there is a hidden constraint that causes 90% of the wrong answer on test 2 verdict. Here's the problem in a nutshell. You have n boxes and your nephew is going to pick any box and empty it, and he's tried to distribute those boxes into remaining n-1 boxes to make them all perfectly equal. Our job is to add the minimum one number of blocks so that he can always succeed, no matter which box he chooses. Pause the video right now and think, what are the two things that must be true for the boxes to be equal? Now, let's discuss the two most important rules or logic to solve this question. We will be doing this with the test case 3 given in the question. It has 0, 3 and 0 blocks in the particular boxes. Let's pick up box 2 and try to distribute the blocks in the two boxes. But it is not possible, as we can't distribute 3 blocks in 2 boxes equally. Here comes the first rule of divisibility. The total number of blocks present in each of the boxes should always be divisible by n-1 boxes. Like, we need to add at least one more block so that the total number of blocks become 4 and it is divisible by 2. Now, let's discuss the core logic to solve this question, which is what must be the maximum height when we are done with the distribution and want equal number of blocks in each of the box. Over here, if we choose box 2 and try to distribute these blocks in the remaining blocks, we can put this block over here and this two over here, and we are able to distribute the blocks equally. But if we choose 1, we can't do anything, or even 3, we can just put this over here or here, but it is not equally distributed. Now let's try to find the target height. Let's call it as k. To find the target height, we have to satisfy two rules. First, which we have already mentioned, that the total sum, let's call it as S, should always be divisible by n-1 blocks present in the question. And now let's move on to the second rule, which is often the reason for wrong answer on test 2. The rule is your target height k must be at least as large as the maximum element currently in our array. Like over here, this must be the maximum height. Like if we choose this or this, we won't be able to balance it out. So this must be the maximum height. Now you can pause and think about why. Suppose if you decide that every box should end up with 5 blocks, but you already have a box that contains 10 blocks. What happens when your nephew picks a different box? He now has to move blocks into a box of 10, but that box is already over the limit. You can't delete blocks in this problem, you can only add them. This means your final height for n-1 boxes cannot be smaller than biggest pile of the blocks you already have. So a target height k is actually maximum of two values. First, the height need to fit a total sum, that is k, and second is the maximum element in the array. So basically our k looks like max of max height m and ceil of s divided by n-1. Once you have this k, the total blocks is simply k into n-1. Subtract your current sum from that and you have your answer. Here's the implementation of the logic. I have already taken the inputs required. Let's begin with finding the max element in the array, for which I need to run a loop and get the max. We also need to find the sum, that is the total number of blocks present. For that, we need to use long because the number of blocks is 10 power 5 and the number of blocks is 10 power 9. If we use int, then overflow will happen. So let's go with long and sum plus equal to long, that here I'm typecasting int to long. Next, we need to find the k, which is the target height required, which this height is the maximum of the max element present in our height and CL division of sum and n minus 1 number of blocks is. So sum divided by n minus 1. This will be a regular division. To do a CL division, we need to add the dividend and minus 1. So which will basically be minus 2. Next, let's find the total number of blocks required, which will be k into n minus 1. So our answer will be total number of blocks required minus the number of blocks we currently have. Let's try to run this, and it's passed. Let's try to run this. And it's done. If you enjoyed this breakdown, let me know in the comments which problem is giving you days to nightmares lately, and happy coding!